Hi everyone. In this video I'm going to discuss the material in Chapter 12 where we explore how we can create and use our own programmer-defined classes. So far this semester, the only thing we've actually been using in terms of classes are the classes that are built into our application. So things like forms and buttons and text boxes and labels are all based upon classes that have already been predefined by the program. When we create a form, it's based upon the class of the form, and we just instantiate a specific version of a form, and every form has similar properties and similar methods. When we create a button, it's based upon the button class, and every button that we use has similar properties and methods. And that's very useful for most programs. But occasionally, when we write more complicated programs, we want to design our own classes. Sometimes we want to create what's called a middle layer class or a business class, where we are defining something that we're going to use for our particular industry. And it might be something like a product, or a customer, or an employee, or a process. It might not be something that's tangible, it might not be an object that shows up on the screen, but it's something that we use on a regular basis. And so we're going to go through the trouble of defining it and defining its various properties and methods, things that describe it and things that it can do. And then we're going to use that business class over and over again throughout our organization. The other thing we might want to do is create a database layer so that we can access data that's outside of our program and we can send information to that database outside of our program. So retrieving information and storing information. We've talked earlier in the semester about long-term storage, and this is where we're finally going to visit that idea, is the use of a database class connected to some sort of external database data source. In this chapter, the business class example that we're going to explore is a product class. And the particular product class that we're going to create is going to consist of 3 different properties: a code, a description, and a price. The code and the description are going to be text descriptors, and the price is going to be a decimal value that contains a particular product's price. And this product class is also going to have a method, and it's going to be called GetDisplay Text. And when we use this method, it's going to return a combination of the code and the description and the price with some delimiters as we specify. You can define your own classes with as many properties as you'd like, and the properties can be any data type that you specify. You can also create as many methods associated with your class as you would like. And these are basically verbs that are associated with your specific class. Think about a class as a template for an object you're going to instantiate. So this is the common terminology that's going to refer to any object that's based upon this class. And then you would fill in the specifics by instantiating a specific object based upon the template. We're going to allow for a product to be created in 2 ways. The first, very simple way to construct a product will be to create a product object that has default values. And in our case, the default values will be empty. The other alternative is to create a product where we fill in all of the specific information, its code and its description and its price, right at the very beginning. We'll allow for either of these constructors to occur for our product class, either an empty product or a product where we filled in the details. For this course, we're really only going to focus on a few of the members of a class. We're going to focus on properties, ways we describe something. We're going to focus on methods, actions that an object can perform. And we're going to focus on constructors, how we execute an instantiation of an object based upon a class. Let's review some of the concepts that are relevant to classes and objects. When we are in an object-oriented programming language, we think of an object as something that is self-contained and has properties and methods. It may also contain other members. So for example, a form contains other members that are part of that form. When we create a specific version of a class, it's called an instance, and the action of creating that specific object is called instantiation. One of the key concepts to object-oriented programming is encapsulation. And this is how we manipulate the data that's stored in a particular object and the actions that that particular object can perform. One of the advantages of using our own classes is the idea of data hiding. We can store information inside our class and keep it hidden from the user. And we can reveal it using code so that we can format it properly and show them only what we want them to see, but not the actual data behind the scenes. As I said before, there are lots of different members for classes, but the most common are properties, methods, and constructors, and those are the only members of classes that we will focus on in this course. For our product class, we're going to store 3 pieces of information inside the class, and this is data that's going to be hidden from the user. We're going to store a code, a description, and a price. Note that these are lowercase variables that we're storing inside the product class, and we will never reveal this information directly to the user. It will be hidden inside the class. They're all private. We're going to have 2 different ways to construct a product class. If the user constructs a product but doesn't specify the 3 different properties, the product will be created with an empty set of those 3 properties. However, if the user specifies the code and the description and the price, we will fill in that information behind the scenes. We'll take those 3 pieces of information and store them in our dot code, our dot description, and our dot price. Note the capital letter for code and description and price for the dot properties. These are the places where we're going to reveal the information the user has provided and reveal the information that we have stored secretly behind the scenes. When we create properties for our classes, we use gets and sets. A get is when the user asks for information, and we're going to return what we've stored secretly in the class to the user. Now, we may not return it in its exact format. We may actually make some modifications to it before we reveal it. But in this particular example, we just show them what's in our private variable. For our set, the user is sending information into the class. So we're taking whatever value they provided and we're storing it in our own private variable. In this case, code gets set to value. You can see the description behaves very similarly, where we either send information to the user or receive information from the user. And the price property is also very similar, the only difference being that price is type decimal. In addition to our 3 properties for our product class, we also have one method. It's called GetDisplay Text. It does receive a single parameter, which is a separator, a string. When the user asks for the GetDisplayText to run, it's going to return our private variable code and then append to that the separator. Then it's going to return the price converted to a string and formatted as currency, and then another separator, and then it's going to return the description, all as one long phrase. The separator can be anything, so the user could specify a semicolon or a space or a tab key, and we'll provide this phrase with their user-defined separator. What would specific instantiations of a product look like? Well, here are 2 examples of 2 different textbooks that we could store in the product class. One is the C# book, and one is the Visual Basic book. And you can see that they have codes, a combination of 2 letters and 2 numbers, descriptions, the actual title of the book, and prices. If we wanted to create 2 new instances of our products, we could. And we're probably going to do it something like what we see in the bottom of this slide, where we say that product 1 is equal to a new version of a product class. So we're instantiating an object based upon the product class, and we're setting the code and the description and the price right off the bat. If we wanted to get slightly more sophisticated with our method, we could create an overloaded version. In this case, we would type 2 different versions of the same method. One would receive a parameter, in this case the string separator. The other wouldn't receive any parameters. This makes 2 different versions of the same method. If the user doesn't specify a particular separator, we would have a fallback position. In this case, you can see that the separator would be a comma and a space. Should you choose to create a method with an overload situation, when you type the method someplace else in your code base, you'll get a prompt of having two different ways of using this method. So in this example, you can see they're using 2 of 2, but they could have chosen 1 of 2 where they're expecting a string separator or they're not expecting a string separator. IntelliSense will prompt the user appropriately. It is possible to create a class that has a variety of different methods associated with it, where we're not going to actually instantiate the class. We're just going to take advantage of the methods that we've programmed into that class. And a perfect example of this is a validator class. In order to create a class that you're not actually going to instantiate, you need to add the word static. This allows you to call the specific methods that are in that class without actually instantiating the class itself. In this particular example of the validator class, we're going to create a local private variable called title, and we're going to give it a default value of entry error. And then we're going to create a public dot property called title with a capital T, and we'll do the traditional gets and sets for that property. The validator class will contain a series of methods that we've seen before. So as an example, we'll include an isPresent method, where we'll test a specific text box to see if it's empty or not. If it is, we'll set up a message box that tells the user that their specific entry is missing. We'll focus on that specific text box and we'll return a value of false for the true-false return for this method. If, however, the text box does have something inside of it, we'll return a true. Once we've created our static members for our static class, we can call any of those methods by typing the name of the class, dot, and then the name of the method. We've done this many times with things like convert dot to decimal. But in this case, validator is defined by us and isPresent is defined by us. So these are user-defined methods that are part of a user-defined class. For the example we'll be working through, we're going to use one user-defined business class, and it's going to be the product class, which will have 3 properties, code, description, and price, and one method, GetDisplay Text. For this class, we will have 2 different constructors, a constructor with default values or a constructor with specified values. We're also going to include one static class, which is the validator class. It has a single property, title, and it has a series of different static methods, an isPresent, an isInteger, an isDecimal, and an isWithinRange. And you certainly could include more static methods if you feel that they are relevant for a validator class. The last class that we're going to eventually include for our example is a database class, and we're going to call this the ProductDB class. And it will have 2 different methods associated with it. GetProducts, where we get information from an external file and bring them into a list, and SaveProducts, where we take information from our program and store it in our external file. We're not going to get into the details of how the ProductDB class works. And the good news is, it doesn't matter whether you understand the inner workings of the class. You simply have to be able to use GetProducts or SaveProducts, just like we've been using a variety of built-in methods all semester long without really understanding what C# is doing behind the scenes. In the next few videos, we will work through creating the product maintenance forms that use our product class, our validator class, and our database class. That's it for this video. Thanks so much for watching. See you next time.